So in projectile motion study, there are many types of problems which we have to study, and this is first of its kind. This type is a type where starting and ending position of the projectile is at the same level. What we mean by this is, projectile starts at origin and ends up again on x-axis, that is same level as the origin. Okay, this is the first type, the simplest one. Then later in other videos we are going to do types where projectile starts from one level, goes to other, either above or below x-axis. And in these types no time calculations are involved. The third type, which is going to come up later, is where projectile starts from origin, ends at some level, and we need to find quantities which involve time also. So we are going to come to that, but at the moment our objective for this video is to do problems which are restricted to this type, starting from one level and ending on the same level. And see, these are the standard thing. Initial velocity of the projectile considered as u, projection angle considered alpha, and projection point is origin. H is maximum height, R is the range. So now, for the first problem, data given is there is a projectile which you have projected with initial velocity u at an angle alpha, and let's say it covers range R. Now u, alpha and R are not given to you, but instead what is given is, if alpha was 15, then the range works out to R minus 12, and if alpha was 45, then range works out to R plus 24. Now, what you do in this case is, you write out your standard equation, R is equal to u square sine 2 alpha by g, and put, for the first data, R is R minus 12 and alpha is 15. For the second data, you put R is R plus 24 and alpha is 45. Now, you can solve the last two equations, and you can subtract actually top equation from the bottom. What you land up is finding out u square by g, which is 72, which we use again for this equation, R plus 24 is u square sine 90 by g, and therefore from here we can get value of R, that the correct range is really 48 meters. Now if I use these two quantities which we just derived, u square by g is 72 and R is 48, and again use R is equal to u square sine 2 alpha by g, we will be able to get alpha as 20.9. And there, so this is how we have found, this is how we have solved this problem, by using only single equation, R is equal to u square sine 2 alpha by g. In the second problem, statement of problem is like this: a projectile is to be projected so that it clears a wall 4 meter high located at a distance of 5 meter and strikes the horizontal plane through the foot of the wall at a distance of 4 meter beyond the wall. This also perfectly fits in our type 1, wherein we are going to use standard formulas. Our objective is to find initial velocity u, which is not given, and see, mind you, even alpha is not given. Doesn't matter. We use this equation for the path y is equal to x tan alpha minus half g x square upon u square cos square alpha, and supplement it with another standard equation, R is equal to u square sine 2 alpha by g. Using these two, see, using the second equation, you work out value of g by u square as sine 2 alpha by r, and put it in the first equation, that is y is equal to x tan alpha minus half g square upon u square cos square alpha. So by solving this, we will be able to get, and of course doing some geometry, trigonometry, sine to alpha is to sine alpha and cos alpha. We can go on solving like this, and we will come up with alpha as 60.86. And if we use this alpha, and r is 9, the total range, and we will be able to get the u which was wanted. Next problem goes like this. It asks you by what percentage the maximum range of projectile is increased if initial velocity is increased by 10%. Really simple problem. What you do is you say let initial velocity be u, initial range be r, and range after increasing the velocity be r1. Then increase velocity. See, velocity is going to increase by 10%. Increased with new velocity to 1.1. And all you do is write this equation for initial velocity u and alpha, and again write this equation for range r1, where in place of u, you're going to substitute 1.1 u, that is 10% increased u. Take the ratio. Ratio comes to 1.21, that is range is increased by 21%, and that's what was asked. Next problem goes like this. You are given this data. U is 20, maximum height is 5, and you are required to find range. Simple. First use maximum height is given, so use h is equal to u square cos square alpha by 2g to get you alpha. And once you have alpha, put in r is equal to u square sine 2 alpha by g to get your r. And r comes in this case is 35. Thank you.